You can see there is a very interesting experiment in which there is one flywheel, and that flywheel is going on the two iron rails. These are soft iron rods bent into a typical structure, and that structure is like a railway track, and this wheel is able to run over this track because it has got a magnet in the axis. In this magnet there is one north pole here and a south pole here. So this north and south poles, they are having strong attraction with the soft iron rods. Even though these rods are shining, they are actually soft iron, maybe some nickel or chromium plated, okay. And we can see the contact between the flywheel and the rods is continuous, and it is continuous because it has got a hemispherical shape. It's very interesting. The shape is spherical, and when it goes down, we feel it will fall down, but it doesn't fall, because when it comes down, it will have a not sliding motion, it has a rolling motion. Remember, this is sliding motion. In sliding motion there is lot of friction, but in rolling motion the friction is very less. And when it comes down, suddenly it goes up, because when the rods are going apart, the magnet will try to hold the rod, and it will, because of curvature, it will go from outside to inside. You can see it is going from outside to inside, and again from inside to outside. The same thing happens on the other end also. If the wheel comes down, it goes up, and we can see that the wheel has continuous motion. Yes, you are getting this motion, right? Now, because this wheel, when it starts rolling down, it has got four important quantities. Remember, there are four important quantities. Number one is linear momentum, mass into velocity, linear momentum. Second is angular momentum. It has got angular momentum because it has got rotational motion. Third thing, it has got kinetic energy, 1/2 mv square. And this is linear kinetic energy. Linear means it goes in line. So it's 1/2 mv square. Center of mass is moving down. That is 1/2 mv square. And this is very small velocity. But it has got one more quantity that is called a rotational kinetic energy. And rotational kinetic energy is 1/2 I omega square. 1/2 I omega square. So let us narrate four quantities. Number one, it has got linear momentum. Number two, it has got angular momentum. Angular momentum is I omega. I is the moment of inertia, and omega is the angular frequency or angular speed, angular velocity. Angular velocity omega and I, moment of inertia, they constitute angular momentum I omega, and 1/2 mv square is linear kinetic energy, because the flywheel as a whole is moving in straight line. Even though it is rotating, it has got 1/2 mv square, and it has got 1/2 I omega square. And the surprising thing is that the linear momentum, angular momentum, linear kinetic energy, angular kinetic energy, all these four quantities conserve. Now what is meant by conserve? The total remains constant. They remain constant. And the conservation demands that the flywheel, when it is coming down, will not stop suddenly. It will not stop, but it will change direction because of this metallic contact. You can see that it's all four quantities are conserved, but the direction is suddenly changed, and we can see the flywheel comes from some height, but when it comes down and goes up, again comes down, again goes up, every time it goes to less and less and less height. This is very interesting. You see, now question is why it is going to less height. It is going to less height because it has some loss of energy, some loss of angular momentum, and that loss is because of friction. Now where is the friction? Friction is between the magnet and this rail contact. Friction you can't make zero, you can't avoid. At the most you can apply some oil and make less friction, okay. You can apply some ball bearing, okay. But you can never make zero. You can never make zero friction. That is very important point to be noted. Second thing is that when it is going down, you can see it comes up, again comes up, again comes up, again comes up. Every time go down, comes up, but less height, and ultimately stop. And that is because of friction. Okay, so this is very interesting experiment. Now question is, what is flywheel? Flywheel is a wheel which has got a major mass on the rim, large mass on the rim, away from center. And such flywheel has large MI, moment of inertia. MI, moment of inertia, I you know what is I? Sigma mi ri square. Sigma mi ri square, mass into distance square, summation of all particles taken mass into distance square, and that is called as moment of inertia. Now this moment of inertia mi, which is written as capital I, is depending upon shape, size, mass, distribution of mass and so many factors. But here a flywheel is constructed using a magnet in the axis, and that is why this toy is very special. And using a toy you can learn a lot of science. It is a great pleasure to learn science through the toys, and toys are the best teachers because they give us the authentic knowledge, practical knowledge, and we can play with such toys and learn physics from it. Thank you.